In the previous video, we learned how to name a compound when you're given its formula, and in this video, you're going to go the opposite direction. You're going to start with the name, and you're going to learn how to write the formula for an ionic compound. So in the name, there's no indication of how many of each ion you have. So aluminum sulfide, I don't know if I have 2 aluminums or 3 or how many. So we have to figure out, the key to this is making sure that the total charge of the compound adds up to 0, like we've been talking about. And this is what makes going from name to formula a little bit trickier. So we're going to start with aluminum sulfide. This is an easy one because aluminum is in column 3A and sulfur is in column 6A, so they're both in columns where they follow patterns. I'm going to start by just drawing one of each element. Aluminum has a 3+ charge, and sulfur has a 2- charge. When we look at these two right now, the charges are not balanced out. So you have +3 and -2. They don't balance out. We need more negatives. So I'm going to draw another sulfur. Now we have more negative than positive, -4 versus +3. So I'm going to draw another aluminum, Al3+. Now we have +6 and -4, still not balanced, but we need more negatives. So one more time I'm going to add to my drawing another sulfur, 2-, and now if I look, I have 2-, 2-, 2-, for a total of 6-, and 3+ and 3+, for a total of +6. So it looks like I'm good. I have drawn 2 aluminum ions, so Al2, and I've drawn 3 sulfide ions, so S3. There's also a shortcut method for doing this. I'm going to force you to draw the pictures on some of them because there's a lot more understanding happening there. But you can get to the same formula in a shorter pattern by writing the element symbol and its charge, so 3+ and 2-, and you do what I call the crisscross method. You take the number, not the charge, but just the number, and you crisscross it down to the other element. So this will give you Al2, S3, the same formula we got by drawing pictures. In the second example, iron 3 oxide, we've got that 3, Roman numeral 3 in parentheses. That's a hint that this is one of those transition metals, and that 3 tells us the charge of the iron. So if I drew one iron ion here, it's going to have a +3 charge. If I draw one oxygen, it is a normal one in a predictable column. It has a -2 charge. I got to make sure my charges are balanced. Right now they're not because I have +3 and -2. So I'm going to draw, I've got more positive right now, so I'll draw another negative oxide ion. Then I will draw, now we've got more negatives, so I'm going to draw positive iron. Still not balanced because I have +6 and -4. So I'm going to draw one more negative ion, the oxygen. And we are balanced now with -2 charge, -2 and -2. For -6, and +3 and +3 for +6. So the formula for iron 3 oxide will be Fe2, because I have drawn 2 iron ions, and then O3, because I've drawn 3 oxygen ions. If I did this with the crisscross method, it's going to look similar to the previous problem. Iron's charge was 3+. Oxygen's charge was 2-. If we crisscross the numbers to the opposite atom, we get iron. We have 2 iron ions and 3 oxygen ions. Notice I'm rewriting the formula. You can't leave it as this mess here. That is not a correct answer. You have to write it nice and neat without the charges shown in the formula, because the overall formula has no charge. One more example, magnesium carbonate. Carbonate, it doesn't have that IDE ending, so it's not just an ion from an element on the periodic table, it must be a polyatomic ion. So I'm going to look at that table at the top of my periodic table and find carbonate. Carbonate is CO3, 2 minus. So that whole group, the carbon and 3 oxygens together, have a -2 charge. So let's draw first magnesium. It's in column 2A, and so it has a +2 charge. And carbonate, that's a carbon with 3 oxygens around it, and that whole group of atoms with no charge, but the overall group has a -2 charge. Well, we lucked out on this one because +2 and -2 are already balanced out, so our formula is going to be Mg CO3. There's 1 magnesium and 1 of the carbonate polyatomic ions. Now, something to be aware of, if you use the crisscross method on this one, you'd get Mg2 CO3 2, but this formula is the empirical formula, so the 2 and the 2 to 2 ratio should reduce to 1 to 1, giving you Mg CO3. So if you use the crisscross method, you gotta watch and make sure you still have the lowest whole number ratio.